All right, today we are going to classify triangles, and we're going to classify them by side lengths, and we're going to classify them by angles measured. Okay, so we all know how to name sides, and we know how to name angles. So if you look at this triangle here, we would name the sides AB, we would name a side BC, and we would name a side AC. The angles, we have angle A, angle B, and angle C. If you were to classify this triangle by side length, there's 3 different classifications you could have. The first one is equilateral. That's where all 3 sides have the same length. The second one is isosceles. Isosceles triangles only have 2 of the same side lengths. The last one is scalene. A scalene triangle has 3 different angle or side measures. To classify a triangle by angle measure, there's now 4 classifications. The first one is equiangular. Equiangular corresponds with that equilateral. So if all 3 sides are the same, that means all 3 angles are going to be the same. And what's nice about an equiangular triangle is that every single angle measure in that triangle is 60 degrees. And we're going to talk about this a little bit later, but they all add up to 180. So every single triangle adds to 180. Excuse me. Another angle is going to be a right triangle. So when you see one right angle in a right triangle, this right here, you classify it as a right triangle. Done. The next one is an acute triangle. An acute triangle has all measures less than 180. So let's say we have one angle measure that's 70, and then we have another one that is 60, and so our last angle measure would be 50. All of those are less than 90. The last one is an obtuse triangle, and an obtuse triangle has one angle measure that is greater than 90. So if this is like 112 degrees, your other measures would be, let's say, 60, and the other one would be 8. So again, all adding up to 180, but one is greater than 90 degrees. 2 triangles have specific names for each side of that triangle. Those are right triangle and an isosceles triangle. Right triangle, they have legs, which are the 2 sides that form the right angle. So in this case, AB is a leg and BC is a leg. And we highlighted those yellow. The hypotenuse is the side that is directly across from the right angle. Okay, so AC is the hypotenuse. Isosceles triangle also has legs, and we'll go back to yellow and we'll highlight those 2. The legs are the 2 sides that are the same. So in this case, AB and BC. But it's not called the hypotenuse anymore. It's called the base. The base is that 3rd side of the triangle that is not congruent. So AC. Here we have 3 triangles within here. We're going to classify each of them by its angle measures. And if you think about it, you have right, excuse me, I was going to sneeze. You have right triangles, you have acute triangles, you have equiangular, and you have obtuse. The first one we're going to look at is triangle ABD. Triangle ABD is right here. Here you have 80, 20 right here on the inside, And if you subtract from 180, you're going to get another angle measure of 80. All of these angle measures are less than 90 degrees, so all of these are acute angles, therefore it's an acute triangle. The next triangle we're going to look at is ADC. ADC, the big triangle. If you notice, you've got this guy right there. That's the right angle symbol. So right away, you don't have to know what any other angle measure is. That's a right triangle. And lastly, we're going to look at BDC. BDC. And you can notice right away that one of those angles is greater than 90. Since that one angle is greater than 90, this is an obtuse triangle. Now let's classify by side lengths. There, again, are three triangles. The first one we're going to look at is this one right here. The name of this triangle is HFE. HFE. And if you notice, two of those sides have the little dash marks. That means that they are congruent. So if this has an angle measure of 10, this has an angle measure of 10. Since they are both 10, that means they are equal. And if we have two sides that are equal, because this other side is 12, that means this is an isosceles triangle. Another triangle we have is this one here, HFG. HFG. I'm going to leave that side length of 10 right here because we do need that. So again, triangle HFG. All three of those sides are different lengths. Therefore, this is a scalene triangle. Last but not least, we have a last triangle, the big one on the outside, HEG. HEG. And again, you have 12, 11, and the total length of this side is 14. All three of those sides are different, so it is a scalene triangle. We can also use side lengths in order to find a value of x. So in this example here, you have two sides that are congruent. Congruent, remember, also means equal. So you can take those two sides and set them equal, because we state that they are congruent, therefore you can set them equal. So if you were to take your x's and move them together, you have 2x minus 10.7 equals 6.3. Add together 10.7 and 6.3, which gives you 17. Divide by 2, and x is 8.5. In the instructions, I did not ask you to find x. I asked you to find the actual side lengths. So what we're going to do is we're going to take this x equals 8.5 and substitute it back into the problem. So 2 times 8.5 is 17. And 17 plus 6.3 is 23.3. Now, since we know one is congruent to the other, you can go ahead and substitute that in. Lastly, you need to find the length of that third side. Because it's not an equilateral, we cannot set that one equal to 23.3, so we have to substitute again that 8.5 into x. So 5 times 8.5 is 42.5. And then you add 2 to that and you get 44.5. So this is classified also as an isosceles triangle, knowing that those two sides are congruent. The perimeter of this triangle is 60. Classify the triangle by its side length. So this one we don't know if none of the sides are the same, if two of the sides are the same, or if all three sides are the same. But we do know that the total perimeter, the total outside measure of this triangle is 60. So what we can do is we can take all three sides and set them equal to 60. So if you take all three sides, x, 3x, and 8x, and add them up, 8 plus 3 is 11, plus 1 is 12. And then 12 plus 4 minus 16 cancel each other out. So 16 minus 16 is 0. That's equal to 60. Divide by 12, x is 5. So what we're going to do is we're going to take this x is 5 and substitute it in at each side. So 5 plus 12 is 17. 3 times 5 is 15, plus 4 is 19. And then 8 times 5 is 40. Let me catch up with my writing here. And then 40 minus 16 is 24. So all three of these sides are different lengths. Therefore, again, this is a scalene triangle. We mentioned before that every single triangle you will see adds up to 180 degrees. That is called the triangle sum theorem. That is something that you have to memorize because it's true for every single triangle. Okay, so if we want to solve for all the angle measures, I don't know what type of triangle this is. I can't say that it adds up to a perimeter because that's talking about side lengths. When we're talking angle measures, you're going to do the same thing as the problem we did before, but here we are actually going to set it equal to 180 because we're dealing with degrees. So again, you would add up all of your like terms. So you have 14x, and then you're going to add up all your other numbers. So 17 plus 25 plus 12 gives you 54. Whoops. Gives you 54, and again, that's equal to 180. You would subtract 54, so 180 minus 54 gives you 126, and then divide that by 14. So x is 9. And again, just like before, you're going to take this 9 and you're going to substitute it back into all three angles because we're going to classify by its angles. So you would say 4 times 9 plus 17, which gives you 53 degrees. And then you would say 7 times 9 plus 25 gives you 88 degrees. And then 3 times 9 plus 12 gives you 39 degrees. All three of these angles are less than 90, so this is an acute triangle. If you have any questions, please come in for extra help. Otherwise, have a great day.